This is lesson 4-2, function notation. So what is function notation and why do we use it? Since all functions are rules that we convert our inputs, which we have said is our x values, we convert them into outputs, which are our y values. It makes sense that we have to have the function notation to indicate what the rule is, indicate what the input is, and also indicate what the output is. Function notation can absolutely be confusing because it gives the appearance that multiplication is being done. The last sentence there is a big time stress. You may want to star that, underline it, do something that sticks out. There is absolutely no multiplication involved when you are doing function notation. Notation basically serves two purposes. It'll tell you what the rule is, and it also specifies the given output for whatever the input originally was. So let's do a comparison of what you've seen in the past and what you'll be doing now with function notation. In the past, you would be given the sentence, find the value of y if y is equal to 3x minus 2 and x is equal to 3. So at this point, what you would be doing is taking the x value, which is x equals 3, plugging it in this function here, and even though it says y, it's still a function. And so we would go y equals 3 times 3 minus 2. 3 times 3 is 9. Again, I'm just following PEMDAS procedures. 9 minus 2 is then 7. So when x is equal to 3, y is equal to 7. Now that's a lot of words. And as you should know by now, in math, we try to replace a lot of the words with symbols. What you'll be used to seeing at this point is something like this. And please note how I am saying this. If f of x is equal to 3x minus 2, evaluate f of 3. Again, f of x. That's how we pronounce the function notation. This would be f of 3. The procedure itself is no different. F of 3 is equal to 3 times 3 minus 2. F of 3 is equal to 9 minus 2. So f of 3 is equal to 7. You are done at that point. Here's some examples for you to try. Given the function f of x equals x over 3 plus 7, the first thing I want you to do is explain what the function rule does to convert the input to the output. The second thing, evaluate f of negative 9. The third thing, find the input for which f of x is equal to 13. And finally, if g of x is equal to 2 times f of x minus 1, evaluate g of 6. Pause the video at this point to give yourself a chance to try it on your own. Here are your answers. To start, what we do with the function, it takes the input value, and that is divided by 3. Then add 7. For f of negative 9, we'll put negative 9 divided by 3 plus 7. And that's going to be equal to negative 3 plus 7, which is equal to 4. So f of negative 9, my mistake, is equal to positive 4. Next, find the input for which f of x is equal to 13. F of x we know is equal to the original function, x over 3 plus 7. So in this case, what we're going to do is substitute 13 for f of x and solve the equation using the function. So the first thing I'll do is subtract 7 from both sides. That gives me 6 equal to x over 3. And then we'll multiply both sides by 3 to get 18 equal to x. And finally, and I'll do this right underneath it, if g of x is equal to 2 times f of x minus 1, evaluate g of 6. So g of 6 is equal to 2 times f of 6 minus 1. So now we've got to go back to f of x and find out what f of 6 would be. So I'll do this part up here. F of 6 is equal to 6 over 3 plus 7, which is equal to 2 plus 7, which is equal to 9. So now, going back down to the bottom, we now want to do 2 times 9 minus 1. That's 18 minus 1. So g of 6 is equal to 17. Here's another example for you to try. Let's read it through. Boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table that's actually to the right. Fix that. In this scenario, the temperature T is a function of the number of hours H. Using the chart at the right, we want to evaluate T of 2 and T of 6. We also want to know for what value of H is T of H 76. And finally, between what 2 consecutive hours will T of H be for 100? And explain how you arrived at your answer. Pause the video at this point to give yourself a chance to try it on your own. Here are your answers. T of 2 and T of 6. T of 2 is right here. So T of 2 is equal to 104. Same thing for T of 6. We're just going to look across it. T of 6 is 68. Secondly, for what value of H is T of H equal to 76? I take a look at my T of H column. 76 is right in the middle, and it matches up with 4. So H equals 4. Next, between what 2 consecutive hours will T of H be 100? Explain how you arrived at your answer. The temperature is constantly going down. In the second hour, it's 104. In the third hour, it's 85. So at some point, it will cross over into 100. So it's between the second and third hour because T of 2 equals 104 and T of 3 equals 85. If you're having any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.